Hello, welcome to Super Easy Physics and Mathematics. Today we are looking at GCSE Physics Higher Tier Paper 2. This paper is for 1 hour 45 minutes. We are expected to answer all questions, and there are 8 questions in this particular paper, and the maximum mark for this paper is 100. Let's jump in. Question 1 shows an electric supercar. The battery in an electric car needs to be recharged. Suggest 2 factors that affect the distance an electric car can travel before the battery needs to be recharged. So basically, one, we talk about the efficiency of the battery, the capacity of the battery. Then we look at the speed at which the car is moving. These are some of the factors that will affect it. Then we look at the stopping at traffic lights, then climbing uphill along the road, mass of the car, condition of the road, not using proper pressure inflation for the tire of the car. Question 1.2, write down the equation that links acceleration, velocity, and time. So that is A is equal to delta V over T. So that we have it. Now in this particular question 1.3, we are going to apply this equation. So the maximum acceleration of the car is 20 meters per second. So that is A. Calculate the time taken for the speed, that is T, of the speed of the car to vary from 0, that is U, to 28 meters per second, that is V, at its maximum acceleration. So let's substitute. We have that. So for the substitution, you have 1 mark out of the 3 mark. Then cross multiply. Then make T sort of formula. Then you have the next mark. Then for evaluating this, you have your final mark. So which is 1.4 seconds. So let's go to the next question. In a trial run, the car accelerates at 10 meters per second, so not up to the maximum acceleration, until it reaches its final velocity. Now, distance traveled by the car, 605 meters. Initial velocity of the car, 0, that is started from rest. Calculate the final velocity of the car. So this time, from your equation sheet given to us, we can get the formula that connects. So the square of the final velocity, subtract the initial velocity, the square of it, that will give 2, multiply the acceleration, then multiply by the distance traveled. So this is standard equation. So for substituting your value from the parameter given to us, the initial velocity is 0, then the acceleration is 10, and then distance is, so I just use a color code, so when you follow it, you can know the parameters that are substituted. So for carrying out your substitution, you have 1 mark out of the 3 mark. Then what we need to do now is evaluate how this, so this left hand side 0 goes up, so we are left with V square, then multiply out this. So that gave us, so for carrying out that multiplication, you have 1 mark. Then get the square. To get V, we'll take square root of both sides. So that gives 110 meters per second. So we are through with this question. So let's go to the next. Yeah, question 1.5. Write down the equation that link distance travel with the work force and then the work done. So to do this, you know that work done is equal to force multiplied by the distance traveled in the direction of the force. So for stating this, you have the 1 mark. The last question here, that question 1.6. When traveling at its maximum speed, the air resistance acting on the car is 4,000 Newton. Calculate the work done against air resistance when the car travels a distance of 7.5 kilometers at its maximum speed. So the first thing you need to do is to put this unit here, 7.5, express it in meter. So because kilometer is not the standard unit for distance. So we have that. So we have the 7.5. How did it become 7,500? Kilometer means 1,000. So that means 7.5 times 1,000. So that gives us this value here. So for writing this, you have your 1 mark out of the 3. Even if you can't progress further, at least you just get that. So now the next thing we need to do is to substitute the value given to us. We know the F and then we know the distance, so to get the work done. So you substitute. So the first 4,000 multiplied by 7,000. So for stating that, you have 1 mark. Then evaluate it out. You have the last mark there, which is 30 million joules. So now the equivalent unit for Newton meter. How did we get Newton meter? The force multiplied by the distance. So force is measured in Newton, distance is measured in meter. So the unit will become Newton meter. So 1 Newton meter is the same thing as 1 joule. So this is also can also be written as joule, and we can also put this in standard form. So that will be 3.10 raised to the power 7 joule. So you have the last third mark there. Now let's go to, so this is the last question on this. So let's go to question 2. All right, question 2 has to do with planning experimental investigation. A student used a ray bus to shine light through a glass block. The student investigates how the angle of refraction varies with the angle of incidence. Table 1 shows the result. So the first column, we have the angle of incidence. So it started with the angle of incidence of 10 degrees, and that produced the angle of refraction in the glass block of 5 degrees. Then the next procedure, he increased the angle of incidence to 20. Then the student increased it to 30, 40. So the angle of incidence was increased by 10 degrees. And then the student got the corresponding angle of refraction. So the first we are going to do, if you are going to carry out this experiment to measure the angle of refraction in order to determine the refractive index of the glass block, what are the materials you need for this experiment? So you need the ray bus, the optical board, then tracing paper, the optical pin to track the ray. Then you have thumb tags to pin the tracing paper to the optical board. Then you need a protractor to measure the angle of incidence and angle of refraction. Then you need the glass block that you are going to measure the refractive index. Then you need pencil to trace your line, and then you need ruler to draw straight line. So let's look at what the question is all about. Question 2.1. Describe a method the student could have used to obtain the result in table 1. Your answer may include a labeled diagram. So basically, you are expected here to describe the experimental procedure. So how do you report this type of experiment? So the first thing you need to do is you get your optical board and then pin the tracing paper to the optical board. And then next, you place your rectangular glass block on the optical paper and trace out the outline A, B, C, and D as shown on this board. So you trace out the outline A, B, C, D. So after tracing the outline, you remove the glass block from the optical board and then try to mark construct your normal. You construct your normal parallel to this line AD, the left hand side of the block. Then the point of incidence where the normal will cross the line AB, so we can call that M. So after you construct the normal, you call it M, then label the normal NL. So that is the orange line, so this line, okay. Then after that, for you to have a perfect perpendicular line as a normal, you use your protractor to measure the angle 90 at this point. So you are measuring angle NMA, have to be 90 degrees for your normal to be correct. Then the next thing is to use your protractor to trace the angle of incidence. So you construct line XM. So with your protractor, you construct angle SM such that, so we are going to start with 20 degree, but in the experiment they started with 10 degree. So you can do that, start with 10 degree, then later you vary the angle to 20 degree, vary to 30, vary to 40, and so on until you get to the 80 degree, which is the last angle that the student measure, angle of incidence. So after doing this, so you trace this line, that is the green line, and mark it down. So you measure the angle there, which is 20 degrees. So that is going to serve as the angle of incidence. So the next thing is that you will shine the ray of light along XM, and then the light passes through the block, experience refraction, then emerge out on the side DC. Then you use optical pin to track the path of the line of emergence. So let's continue. So after doing that, you remove the protractor. Then next, so this is the line we've already constructed. So you have the line. So the next thing now, so use your ring burst to shine the incident ray along the line SM with the angle of incidence of 20 degrees. Then the ray of light passes through the glass block and emerge on the side DC. Then you can use your optical pin to track the direction of the line after emerging from the glass block, and then you label the 2 points. At least the distance between the pin should be not less than 5 cm. So KP. So use your optical pin, position one here at K, then position the next one at P. Then you can label them KP, those points KP. Then the next thing you are going to do, you remove the glass block. Okay, after you remove the glass block, well, before you trace this line, you have to place back the glass block on the outline ABC, okay, before you use the rail bus to track the direction of the light. Okay, so just take note of that. Then the next thing that you are going to do, you remove the glass block. Then you have to extend this line remove the optical pin from position K and P, then use your ruler to draw the line from P to K and then extend it until it meets the side of the outline DC at O. Then from this point O, you use your ruler to trace the line from O to M. Okay, so use it to trace the line from O, this point here, O to M. Then after that, you now have your angle of refraction, which is angle OML. So you have that angle there. So you can now use your protractor to measure the size of this angle here. So which is the angle of refraction. So the angle of refraction, that is R. Angle LMO. Then after doing that, the next thing you need to do, you record the angle of incidence 20 and the corresponding angle of refraction that you have measured. Then you can now repeat the procedure for other angle of incidence that you now repeat for bigger angle of incidence 30, 40, 50, 60, 70 and 80 as recorded in the book. So that is the process for carrying out this experimental investigation. Now, in this particular question, so this is an incomplete graph for the result. That is now complete figure 2 using data from table 1 and label the axis. Plot the remaining data and draw the line of best fit. So you are expected to do 3 things. So then this is the value. I just decide to bring the necessary values you need here in the short point so we can easily use it to do the plotting. So the first thing, let's identify the axis. So if you look at on the vertical, you have 0, 5, 10. So that will be the angle of refraction and is measured in degree. Then the horizontal line, you have 0, 10, 20 up to 80. So that will give you the angle of incidence. So let's label the axis. So you have the angle of incidence and the angle of refraction. So the next thing we are going to do is to plot the value. So the first 3 points have been plotted up to 30 degrees. So let's look at the angle of 40 degrees. So when the angle of incidence was 40, the angle of refraction was 19. So we plot that very particular point. Then next, when the angle of incidence was 50, the angle of refraction was 23. So you plot that point. Then we have when it was 60, then so we finish up the plot. So we've done that for 80. So the next thing is to draw your line of best fit. Now the line of best fit is going to be a line. So if it's going to be a straight line, then the number of points that on the right and to the left must be equal. So let's trace, we can do that. Or the other way again is to connect all the points with a curve. So there are 2 ways you can draw your line of best fit. You connect each of the points with a curve since it's a perfect curve. So it might not be a straight line, but you have a curve. So you also be marked right. So let's see. So with this, I think we have finished all the points. So we have the 3 points. The first point is for proper labeling of the axis. Then the second one for the plotting. And then the third one for the line of best fit. So let's go. Question 2.3 Complete the ray diagram to show the reflection of light from the surface to a plane mirror. You should draw the normal and then draw the reflected ray. So in this case, this is the incident ray and then this is in plane mirror. And you know that then the law of reflection, the angle of incidence is always equal to the angle of reflection. So what we need to do, you draw your normal, you use to draw the normal and get it perfectly, you must position your protractor. So you use it to mark, you put a dot and then you connect a line from the point of incidence to this point. Then the next thing, this is the normal. So you look at the angle of incidence. The angle of incidence is measured from the normal. So the angle of incidence is, this is 10, 20, 30, 40, 50. So it's about 53 degrees. So this 53 degrees. So then on this other side, so you mark your angle of reflection must also be the same 53 degrees. So you put it on the corresponding point. So you have 10, 20, 30, 40, 50, 53 degrees. So that and that. So with that, you remove your protractor. So this is the line that you are expected to draw using the principle of reflection of light. Now, question 2.4, two students investigate the reflection of light by a plane mirror. So then this figure shows the equipment they use. So you have method 1 and method 2. Now, the question is, explain two-way method A is better than method 2. So if you look at method A, the line is thin. The laser light that is used here is thin, so you can easily measure the angle. And then here the protractor is well positioned. So the protractor is attached to the instrument, so it's easier for you to avoid error. And then you can easily mark the incident ray and the reflected ray. But in this case, the beam that is used here, you have a beam of light, but here you have this more of a ray of light. So method A will eliminate error, and then the protractor is positioned to it. So one, the protractor is drawn on the paper, you don't have to move it. So then the second one again is that when the protractor, because the protractor is drawn on the paper, you are more likely to record the correct angle of incidence and reflection. And then thirdly, you say the line are thinner. So the rail in method 1 are thinner than the rail in method 2. So with that, we have finished with the 16 mark for question 2. So we have to go to question 3. Speed limit on road increases safety. The braking distance of a car increases as the speed of the car increases. Give two other factors that increases the braking distance of a car. So if you look at that, you look at wet road, then you also have poor condition of brakes, poor condition of tires, then when the teeth of the tires are worn, then you have increase in mass of the car, then you have going through negative gradient, that is going down the hill. So those are the factors that increase the braking distance. Now, explain why the driver reaction time affects the thinking distance of a car. Now, from the formula for distance, you know that distance is equal to speed multiplied by time. So the longer the reaction time, the longer the braking distance. So that is just what you need to know. So let's go to the next question. Now, scientists have investigated how drinking alcohol affects a person's reaction time. So the table shows this. So we have the broken line, the dotted line is before drinking, that you have the normal, then you have the full curve, that is after drinking. So if you look at this reaction, which of the following conclusion can be drawn from the figure 5? Now, first of all, let's look at the reaction time. The mean reaction time before drinking is about 0.52 seconds. that is before the person takes alcohol. Then the number of people, we can look at that. Then the mean reaction time after drinking alcohol, the reaction time increased to 0.85 seconds. That is 8.5 seconds. So that is the reaction time increase. So you discover that drinking alcohol for ordinarily will increase the reaction time for most people. Now, if we also look, we can look at the number of people that have the reaction time of this. That is 39 people can think within a shorter time. Then after drinking, the number of people that can think within this time become 32. So you discover that. So what is the conclusion we can draw here? One, the mean reaction time increases after drinking alcohol, and then also the change in the reaction time is not the same for all the people after they drink alcohol. Some people will react faster, so you discover like some people here, it's not necessarily affect them. So, but these other people here, this majority of the people were affected. So like 32 people were grossly affected. So if you look at that. Now, so let's go to the and look at the board. So we've already talked about them. So this one is not, we don't have that. Then that is correct. Then the next one, then this, and then this. So the two ones you expected to tick are these two. Now, figure 6 show some speed camera on the road. The speed camera determines the average speed of the car. So if the car is the car is driving from this point down to this side. Okay, so the camera is recording the average speed of the car. Now you discover that one thing is common as you are driving like this. If the speed is constant but the velocity is not constant because the road is not straight. So because there is the direction factor to the velocity. So let's look at this. Now the speed limit on the road is 20 meters per second. The camera in figure 6 are 1.5 kilometers apart. Calculate the minimum time it takes to travel 1.5 kilometers without breaking the speed limit. So what you need to do, remember, you need to convert the 1.5 kilometer to meter. So meter is the standard unit of measuring distance. So in order to do that, the formula for distance is equal to speed multiplied by time, and then from there time is equal to distance divided by speed. So if we have that, just substitute your value. So the time is 75 seconds. That is the time taken for it not to break the speed limit. So the average speed of a car between the camera and the average velocity of the car between the cameras are different. Explain why. Why something is just by reason speed is a scalar quantity, while velocity is a vector quantity. That is one difference. So the speed might be the same, but the velocity will be different because velocity being a vector have both direction and magnitude. So it has a magnitude. So the magnitude may remain the same like the speed, but the direction, once there is a variation in direction, then the velocity is going to have a different value. So the issue is that velocity is a vector quantity, while speed is a scalar quantity. So that is one reason for the difference in the value. So, and then the second, the road is not straight, therefore the direction changes, and then once there is a change in direction, so the velocity also changes between the camera. So these are the three things you need to say in order to get. So we have finished with the 13 mark on this question. So the next one is question 4. Question 4. Hailstones are small balls of ice. Hailstones form in cloud and fall to the ground. Now figure 7 show different size hailstone on the hand of this person here. Now hailstone fall from a cloud and accelerate as they fall down. So why does the hailstone accelerate? Well, there is a resultant force acting on the hailstone as it falls, so which is the weight. So the weight of the hailstone, that is what pulls it down. So there's a resultant force acting on it. So question 4.2, the hailstone stop accelerating and reach terminal velocity as it falls. Explain why the hailstone reaches terminal velocity. Now what is going to happen is that initially as the velocity of the hailstone increases, hail resistance increases. So that is one thing. So as hailstone, once it's released from the cloud, as it's dropping, its velocity initially will start increasing, and then as it's increasing, hail resistance will also increase. Then it will get to a point where the hail resistance will balance up with the weight of the hailstone. So at that point, it has attained the highest velocity until hail resistance balance up with that, and then it attained at that point, so it attained the maximum velocity, and so there is no more resultant force acting on it vertically. And so at that point, it starts moving with the constant highest velocity it has attained at the highest speed, so which is called the terminal velocity. Now, scientists investigate how the mass of hailstone affect their terminal velocity. So we look at this. So we have the various mass, and then you have the terminal velocity. For example, if you look at the hailstone of a 10-gram hailstone, so what is the velocity? That is 4 meters per second. Then when the hailstone is 20 grams, then the velocity become 32 meters per second. So a 10-gram hailstone. So this graph tells you the terminal velocity for different masses of hailstone. So let's do that. Okay, why does the terminal velocity increase with mass? Now we have this option. As mass increases, the cross-sectional area of the hailstone increases. That is not the reason, no. As the mass increases, the volume of the hailstone increases, no. As mass increases, the weight of the hailstone increases. So that is the correct answer. So the terminal velocity, because it is the weight that is making it to drop fast. So the terminal velocity has a relationship with the mass, and the mass is what produces the weight. So the correct answer here to be ticked is the third one here. Now, explain the difference in the maximum kinetic energy of a hailstone with a mass of 10 grams and with a mass of 20 grams. So you have 3 marks. So the first thing, you know that the kinetic energy depends on both mass and velocity. So K is equal to mv squared. So we have that. So this one is just a guide for us to be able to carry out the calculation. And then the next thing again is that as mass increases, so mass is directly proportional to kinetic energy, and then the kinetic energy is also directly proportional to the square of the velocity of the terminal velocity of the hailstone. So now, so for us to calculate the difference, what you have to do, substitute the value. So from the graph given to us in this question, you can trace that the velocity of a 10-gram hailstone from the curve is 4 meters per second. The terminal velocity is still 4 meters. And then the terminal velocity for the hailstone with 20 grams is 32 meters per second. Now, so what I've done in this place is that I've divided the mass by 2. So 20 divided by 2 will give me 10. And then this one here, we also divided the mass, which is 10 divided by 2, will give me 5. So that's why we have this 5 here. So substitute and eliminate and carry out your subtraction because you are looking for the difference. So you have 10.16 joule. All right, question 4.5. The kinetic energy of a hailstone is measured in joules. Which of the following is the same thing as 1 joule? So let's just get the link. So we want to find out is 1 joule equals to Newton meter, or 1 Newton per meter, or 1 Newton per meter square. This is the formula for pressure, or 1 Newton meter square. So we want to find out which one is equivalent to 1 joule. So let's go to the formula for calculating energy. Energy is equal to force multiplied by distance, where energy is represented by E, force is F, and distance is D. Then the energy of 1 joule is set to be transferred when the force of one distance adds through the distance of 1 meter. So the unit of force is Newton, and then the unit of distance is 1 meter. So therefore, 1 joule is equal to 1 Newton meter. So that gives us the correct value for 1 joule. Let's go to the next question. Right, now this diagram repeats the relationship between the terminal velocity of the hailstone compared to the mass of the hailstone as it falls. And if you see that the terminal velocity is inversely proportional to the mass of the hailstone in gram. But we're going to relate it to the question, a hailstone hits the ground at the terminal velocity of 25. So we're going to look at the velocity at which the hailstone hits the ground, and then we look at the mass of the corresponding hailstone. So if you track it, so now the hailstone hit the ground with the terminal velocity of 25, so you can track it here, then 25 meters per second. So let's find the mass of the corresponding hailstone. So that gives us about, the mass of the hailstone will be 18.5 gram. Now the hailstone, on striking the ground, the impact took 0.06 seconds to stop moving. Determine the average force on the hailstone as it hits the ground. So let's go to the next question where the space is provided, and we can now use Newton's second law to calculate. The hailstone hit the ground. We've already said that determine the average force. So we can use, first thing we're going to do is to calculate this mass of the hailstone. So we found that from the graph that the mass of 18.5 has a terminal velocity of 25 meters per second. So for being able to identify that from the graph, you have 1 mark out of the 3 mark. Then the next thing we're going to do, let's look at the formula to determine the force of impact. So from Newton's law, so we know that impulse, that is the impulse, that is change in impulse, change in momentum divided by time, which will give us the impulse. So change in momentum divided by time is equal to the force of impact. So we know the mass of the hailstone, we know the terminal velocity, so divide it by the time. So if we have that, now what you need to do is that this mass in gram must be converted to kilogram. So you divide it by 1000. So that is why the value here becomes 0.185. So which is converted, the 18.5 gram is converted to kilogram. So you multiply by the velocity, terminal velocity, then divided by the time of impact. So for carrying out this substitution, you have the second mark out of the 3 mark. Then simplify your calculation to get your value. So the force of impact is about 7.0 83 Newton. So for getting the final answer, you have the third mark. So that is the answer for this question. We finished the first 4 questions, which is the part 1. It's just to make the video easy for you to follow. And I know that you are a brilliant student who want to succeed. More tutorials solving past exam questions will be uploaded, so subscribe to keep up to date. Please click like, comment on the video, and feel free to ask any question and make room to reply you. So go to part 2 to continue from question 5 to 8.